Dear students, in this video lecture, we are going to discuss one more problem from Unit 1. So this is the question. I'll read out the question first. Suppose a 128 kbps point-to-point link is set up between the Earth and a rover on Mars. The distance from the Earth to Mars when they are closest together is approximately 55 gm. So gm is nothing but gigameters, and data travels over the link at the speed of light is 3 into 10 to the power of 8 meter per second. So here we have three important information. So one is the distance. What is the distance? The distance given here is 55 gigameters. So one given data is distance. The distance between Earth and a rover on Mars is 55 gigameters. And the next information is speed of light. So you can consider speed of light as propagation speed. The propagation speed is 3 into 10 to the power of 8 meter per second. And one more information is given, that is the bandwidth. So what is the bandwidth? The bandwidth is 128 kbps. These are the three information is given in the problem. So what is the first question is? The first question is calculate the minimum RTT for the link. So what is RTT? RTT is nothing but round trip time. Okay, how to calculate the RTT? So first you have to calculate the propagation time or the propagation delay. What is the formula for it? The formula for calculating the propagation delay or propagation time is distance by propagation speed. So what is the distance? So the distance is 55 gigameter. In order to convert this into meter, I have multiplied 55 with 10 to the power of 9. So thereby it will become meter now. Divided by speed. What is the speed of the light? The speed of the light is 3 into 10 to the power of 8 meter per second. Now the final answer would be in seconds. So what is that? When you divide it, you will get the value as 184. So to calculate the round trip time, you have to multiply this time into 2. So what is that? That is 2 into propagation delay, which is nothing but 2 into 184 seconds. So which is 368 seconds. So this is how you have to calculate the round trip time. So what is round trip time? From the sender to the receiver, again from the receiver to the sender. What is the total time required to pass a message from the sender to a receiver? Again an acknowledgement from the receiver to the sender. The total time it takes. So that only we refer it as round trip time. Round trip time is 2 into propagation delay, which is 368 seconds. So this is how you have to calculate the round trip time for the link. So the next problem we are going to discuss here is how to calculate the delay into bandwidth product for the link. Delay into bandwidth product for the link. In the previous step, we have found what is the propagation delay. The propagation delay we have found it as 184 seconds. So bandwidth, it is given in the question itself. What is that? That is 128 kbps. That is 128 kbps. So in order to represent this kbps in terms of bits per second, we just multiplied 128 with 10 to the power of 3. Now your bandwidth is in bps. That is bits per second. So how to calculate the delay into bandwidth? So you can just multiply delay and the bandwidth. Both are already available with us. So what is the delay? The delay is 184. And what is the bandwidth? The bandwidth is 128 into 10 to the power of 3 bits. So when you multiply 184 with 128, you will get into this 10 to the power of 3. For this 10 to the power of 3, I have added 3 zeros here. So the when you multiply all these 3, you will get 2355 to 3 zeros. Okay, now it is in terms of bits. Now we have to convert this in terms of megabytes. So 1 bit is equal to 1.192 into 10 to the power of minus 7 megabytes. So what I have done here is, so to convert this in terms of megabytes, I just multiplied the value with 1.192 into 10 to the power of minus 7. So I'll be getting my final output as 2.81 MB. So this, in case in examination, if this is asked, you please try to remember this. So 1 bit in terms of megabyte, it will be represented as 1.192 into 10 to the power of minus 7 megabytes. So now the delay into bandwidth product for the link is 2.81 megabytes. If it is m small b, then it is megabits. But this is both, this is capital B, so this is megabytes. Okay, now the third question is, a camera on the rover takes picture of its surroundings and sends these to Earth. How quickly after a picture is taken can it reach mission control on Earth? Assume that each image is 5 MB in size. Okay, so now here we have to calculate the transmission time, because after a picture is taken by the rover on Mars, it is transmitting to the Earth. So we have to calculate the transmission time. How much amount of time it takes to reach from the Mars to the Earth. And also the image size or the message size is given here is 5 MB. Okay. So here the given message is 5 MB. Message is nothing but here the image, right? And bandwidth. So what is the bandwidth? Bandwidth is 128 kbps. So that we have written here is 128 into 10 to the power of bits per second. So now we have to calculate the transmission time first. So how to calculate the transmission time? As you all know that we have a formula. The formula is transmission time is equal to message size by bandwidth. Okay, so what is the message? Message size, the message size is 5 MB. Okay, so here we have made little bit of conversions. Okay, to represent your answer, to represent your final answer in terms of seconds, we have made certain conversions here. Okay, so what is your size of the, what is the measurement of the image? The measurement of the image is given in MB. The measurement is given in MB. So as you all know that 1 MB is equal to 8 megabits. Okay, so what I have done is I have converted megabyte to megabits first. Okay, so how the conversion would be? So 5 into 8. When you multiply this 5 with 8, it will become megabits now. Right? So we have to represent our final answer in bits. So what is the thing? So 1 MB is equal to 1048576 bits. So I have multiplied again with 1048576. So what is this is how I have represented the message. Okay, divided by what is the bandwidth? The bandwidth is 128 into 10 to the power of 3. So when you multiply 5 into 8, it is 40. 40 into 1048576, you will be getting 41,943,040 divided by 128 into 10 to the power of 3. So which is nothing but 328 seconds. So that is the transmission time. That is the transmission time. So what is the transmission time? So the transmission time is 328 seconds. So now we have to find out the total time. So how to calculate the total time required? The total time is transmission delay plus the propagation delay. So what is the transmission delay? Just before we have found out. So that is nothing but 328. And what is the propagation delay? So this is what we have found out in our previous slides. Okay, so what is the propagation delay? The propagation delay we have found it as 184. When you add it up, you will be getting 512 seconds. So this is the total time required. So I hope everyone understood this problem. Thank you so much. Thank you all.